Hey everyone, I'm Pavel, and today we're diving deep into one of the most essential tools in blockchain development that you've probably heard about but not fully understood: subgraphs. If you ever tried to query blockchain data directly and felt overwhelmed by slow RPC calls, complex transaction logs, or the nightmare of running your own blockchain node, this video is for you. By the end of the video, you'll understand exactly what subgraphs are and why they're game changers for Web3 development. And most importantly, you'll build your very own subgraph from scratch to index an ERC20 token. We'll be using the Zircuit token as our example, and I'll walk you through every single step. So grab your coffee, fire up VS Code, and let's turn that messy blockchain data into something beautiful. All right, let's start with the basics. What exactly is a subgraph? Think of a subgraph as your personal blockchain data assistant. It sits between the raw blockchain and your application, constantly watching for events, processing them, and organizing everything into a nice, queryable database. Some common use cases for subgraphs include DeFi applications, where we track token swaps, liquidity pool changes, and lending and borrowing events; NFT marketplaces, where we index token transfers, sales, and metadata changes; DAOs, where we monitor proposal creation, voting, and execution; gaming, where we track in-game asset transfers and player achievements; and finally, analytics platforms, where we can aggregate blockchain data for insights and reporting. Here's the problem subgraphs solve. Blockchain data is stored in a way that's optimized for security and decentralization, not for easy querying. Without subgraphs, if you wanted to find all token transfers for a specific user, you'd have to run your own archive node, download gigabytes of blockchain data, parse it through thousands of blocks, filter through millions of transactions, and hope your queries don't time out. Subgraphs are built on three key components. First is the manifest. This is your subgraph.yaml file. Think of it as the configuration that tells the indexing service, hey, watch this smart contract, listen for these specific events, and when something happens, run this code. Second, the schema. This is your schema.graphql file. It defines the structure of your data. Essentially, you're designing your database tables, but using GraphQL syntax instead of SQL. Third, the mappings. This is your TypeScript code that runs whenever an event occurs. It's the business logic that transforms raw blockchain events into the structured data you defined in your schema. Now, why are we using GraphQL? Well, first is the flexibility in data retrieval. GraphQL allows clients to request only the data they need. Next is the strongly typed schema. Queries are validated against a schema, ensuring consistent responses. And finally, real-time updates. Subgraphs enable applications to receive real-time data updates efficiently. Whether you're building a DeFi protocol tracking swaps and liquidity, an NFT marketplace monitoring sales, or a DAO platform following governance votes, subgraphs have you covered. Now for the fun part. Let's build our subgraph. We're going to create a subgraph that indexes the Zircuit token, tracking transfers and holder balances. This is a perfect example because ERC20 tokens are everywhere in Web3, and the patterns we'll learn will apply to virtually any smart contract. Here's what we'll track. We'll track the token information like the name, the symbol, the total supply. We'll also track every single transfer between all of the addresses. We'll then track the real-time balances of each and every single address. Here's an example. So we have the token address, we have the ZRC symbol, and we can also see the top holder information with their balances as well. All right, so let's dive in. We want to navigate to the ZRC token subgraph. We want to clone this repository, navigate to our console, and clone that. Let's navigate to schema.graphql. Now the schema is where we define our data structure. So our token entity stores the basic information of the token. So this is the name, the symbol, decimals of that token. Now we go into the account. So notice the derived from. These create automatic relationships. We don't need to store this data twice, and GraphQL automatically finds all transfers where this account is either the sender or the receiver. Note that transfer events are immutable. This means that they will never change. Once I send a transaction, it will always be there. Next, we want to open the subgraph.yaml file. And this manifest tells our indexing service what to watch and how to process it. So over here, we're using the Zircuit mainnet. We're tracking the token contract. We are using this ABI over here, the token.json, which can be found on the Explorer if we go into the contract and we see the ABI right here. So this is the exact same ABI that's pasted into here. We can also see the start block, which it occurs. We can see the different types of event handlers as well. So right now we're just tracking the transfer events, but we can do things like approvals or any other type of event that gets emitted by the token. This configuration is like giving the indexing service a roadmap. Start watching from this block, listen for these events, and when they happen, call these functions. Now for the meat and potatoes, the mapping logic. This is where we transform raw blockchain events into our structured data. Let's start with our helper functions. So the first helper function is loader create account. This pattern loader create is everywhere in Subgraph development. We're checking if an account already exists in our database, and if not, we're creating it with default values. We're also doing the same with the token. So if the token doesn't exist, so in this case, like on an initial load, or if the token gets updated, for example, the total supply might change, then in that case, this would be updated as well. Next, we have handle transfer. And this is where we load on our accounts, update the balances, and then do additional processing if certain conditions are met. So like if we're transferring to ourselves. Notice that we're using try over here. So this prevents our subgraph from crashing if any of these contract calls fails, if it reaches a method that it just can't process, that if it hits that, then the subgraph is still going to be valid. So also notice that we're creating a unique event after each transaction, but also after each interaction. So after each, there's a unique ID for the individual transaction, but also if that transaction has multiple different events. So for example, if we have a multi-transfer that occurs, for example, if you're using a multi-send, that way you can see exactly each individual record within that multi-send. All right, so now that we reviewed the code, we can now go in and actually generate. So assuming that we've already installed the graph, if you haven't, we can do it very quickly. All we have to do is we have to type in npm install -g graph protocol graph CLI. And that will give us a global install of the graph CLI. All right, perfect. Now we do graph code gen. Oh, we need to first enter our. Perfect. We have the generated files, and now we can build. Oh, we need to first install, of course, all of the packages. Perfect. Awesome. So everything worked. We have built our subgraph. Now we're ready for deployment. We're using a service called GoldSky, but you can use any type of subgraph deployment service. This basically makes it easy for you to deploy and manage your subgraphs without requiring things like nodes, things like running your own infrastructure, Essentially, this helps set up the initial connection so that you can start calling this data. So you don't need to worry about any of the infrastructure setup. So we're using a service called Gold Sky. So we will log in to our Gold Sky account, and we will paste in our API key over here. So now we will actually deploy our subgraph over here. Perfect, and we got our API. So we have this endpoint. And then if we go into here, we can see our ERC20 token subgraph, and we've just started indexing. So this process will take some time since we're indexing every single transaction since the start. We can come in and we can actually start querying different data. So let's get the token info. So if we go over here, we can come in and we can actually get the token info from here. Oh, no, make sure to comment this. Yep, and we have all of that relevant details right here. So we can also see the actual public link, what the percentage of that indexing is. So we go over here, and then we can also see the different types of holders. So now, of course, since this is so early on in the actual indexing process, this will not show us the current top holders, but we can see the different balances there are. And I guess if we query again, we might see different values over here. But yeah, that's the different parts associated with it. So let's recap what we've done. We've taken a subgraph. We have created a production-ready subgraph that indexes ERC20 token data. We've designed a flexible schema that captures transfers, approvals, and balances. We've implemented robust mapping logic with error handling. We've deployed to an indexing service. We can now query blockchain data as easy as any web API. Thanks for watching. If this tutorial helped you level up your development skills, leave a comment, smash that like button, and I'll see you in the next one.